Arrays give us the opportunity to store multiple data of same type, like an integer array. But there is one problem. Arrays are fixed in length, and many times we don't know how many data we'll have to put in the array. Let's say you have this array. It has a length of 5. To add another item to the end of the array, can we just simply put it in the end? No. Remember the video about array and how they are created? These 5 blocks are reserved for us, and accessing the 6th block is illegal. In order to add an item, we will have to reserve another 6 blocks from the memory stack and copy our array there. Then add the last item. Okay, besides inserting in the end, we also need to insert in the middle. What do? We will have to reserve new chunk of memory, put all items from their center to their next position, then add the item. Imagine this situation where there are thousands of data in an array, and then you decide to insert one item in the end, or even worse, in the middle. Wouldn't it be easier if we could say that after the 5 elements, the 6th element can be found at this location? So we could insert as many items as we want in the memory and simply link them. Here is where we have a solution. Linked list. A linked list is a linear data structure. A linked list is consisted of nodes, and there are two things inside a node: the data or value and a link or reference to the next code. Let's try them in our code editor. We will have a node structure or package that will contain the value and a reference to the next node. Now let's define two nodes. Both of them have values but no link to other nodes. We want to put list2 after list1, so we assign list2 in the next node of list1 and list3 after list2. We can access them like so and can go very deep. Do you understand the concept? We only reserve memory if we need and then link them. This saves not only memory but also reduces CPU usage. You won't be able to understand it correctly unless you implement it yourself. So try to do something more with the linked list.